this session, I am going to discuss about difference between BMO and ABMO, energy level diagram for molecular orbitals, bonding in some homonuclear diatomic molecules, difference between the atomic orbital and molecular orbital. Atomic orbitals are monocentric in nature, molecular orbitals are polycentric. The shape of the atomic orbitals are spherical, dumbbell or double dumbbell. Shape of molecular orbital is complex in nature, and atomic orbitals are represented as S, P, D and F. But molecular orbital is represented as sigma, sigma star, pi, pi star. Atomic orbitals are less stable and molecular orbitals are more stable. It's about difference between the atomic orbital and molecular orbital. Next one, difference between the bonding molecular orbital and anti-bonding molecular orbital. Bonding molecular orbitals are formed by symmetric combination of atomic orbital. ABMO is formed by asymmetric combination, means it's by addition, it's by subtraction. And the BMO has less energy, ABMO has high energy. In BMO, the bond formation will take place. In ABMO, there is no bond formation. In BMO, it may or may not have node, but in ABMO, it always has a node, means where probability of finding the electron is 0. BMO is represented as sigma and pi. ABMO is represented as sigma star, pi star. Energy level diagram for molecular orbital. What is energy level diagram? Energy level diagram means it is a graphical representation of all the molecular orbitals in increasing order of energy. If the molecules contain less than or equal to the 14 electron, we follow the electronic configuration like this. If the molecule or ion contain more than 14 electrons, we follow this order. Why this change will happen? Because in this, the 2s and 2p mixing is possible. This is the energy level diagram, less than 14 or equal 14 electrons, and this is about orbital diagram greater than 14 electrons. Here you can see the difference in molecular orbital diagram. Bonding in some homonuclear diatomic molecules. Homo means similar, diatom means atomicity is 2. For example, hydrogen molecule, we know that electronic configuration of hydrogen is 1s1. Here the molecule is present, therefore its electronic configuration is 1s2. According to the molecular orbital theory, we are writing the electronic configuration like this: sigma 1s2. We are placing one electron, here placing one electron. When they are overlapped, they form sigma bond, means in this portion we are filling the 2 electrons. The filling the electron will follow the Aufbau principle, Hund's rule and Pauli's exclusion principle. We can calculate the bond order for hydrogen molecule. Bond order is equals to number of electron in bonding molecular orbital, sigma, and this one is the sigma star. Sigma means bonding molecular orbital, sigma star means anti-bonding molecular orbital. Electron in bonding molecular orbital minus electrons in anti-bonding molecular orbital divided by 2. In bonding molecular orbital, it contains only 2 electrons, here 0. Therefore 2 minus 0 divided by 2 equals to 1. And in this diagram, there is no unpaired of electron in bonding and anti-bonding molecular orbital. Therefore, hydrogen molecule is diamagnetic in nature. Second example, hydrogen ion H2 plus. H2 plus means we are removing the one electron from hydrogen molecule. When we remove one electron, the electronic configuration become 1s1. We can write the electronic configuration according to the MOT, sigma 1s1. And this is the diagram for H2 plus. So here there is no electron. Here only one electron is present, and it is goes to the lower energy orbital, that is BMO sigma, and this is the sigma star. So only one unpaired electron is present. Therefore H2 plus is paramagnetic in nature, and the bond order is, in bonding molecular orbital one electron is present, 1. In anti-bonding there is no electron, 0, 1 by 2. Helium molecule. Electronic configuration for helium is 1s2. Here 2 helium is present. The electronic configuration become sigma 1s2 sigma star 1s2, means totally it contains 4 electrons. In ABMO and BMO it contains pairing of electron. Therefore the bond order become 2 minus 2 divided by 2 equals to 0, and the magnetic nature is diamagnetic. In nature, the helium molecule does not exist. Helium ion means one electron is removed. From 4 electrons it become 3 electrons. This is the diagram. From here one electron is removed and it become unpaired. Because of this unpairing, this molecule become paramagnetic, and the bond order will be 2 minus 1, 1 by 2. The bond order is 0.5. Lithium electronic configuration or its atomic number is 3. Therefore it contains total 6 electron in lithium molecule. We can write the electronic configuration like this: sigma 1s2 sigma star 1s2 sigma 2s2. This is the energy level diagram. Total 6 electrons are present. We start filling like this. Total 6 electrons, 1 2 3 4 5 6. 6 electrons are filled, and the bond order will be 1, because in bonding molecular orbital there are 4 electrons. In anti-bonding molecular orbital only 2 electron is present. 4 minus 2 divided by 2 we get 1, and there is no unpaired electron. Therefore lithium molecule is diamagnetic in nature. Next, beryllium molecule. Beryllium atomic number is 4. In beryllium molecule it contains total 8 electrons, and we start filling the electron in orbital 1 2 3 4 5 6 7 8. Like this, once it is filled completely, we can calculate the bond order. In bonding molecular orbital it contains 4 electrons. In anti-bonding molecular orbital it contains 4 electrons. Therefore bond order is 0. When bond order is 0, the molecule does not exist in nature. It is diamagnetic in nature. Next, boron. Atomic number is 5. In boron molecule it contains total 10 electrons. 10 electrons, we can write the electronic configuration like this. While writing the electronic configuration, we are not write like this. Px2 is equal to pi 2py0, because these two orbitals are equal and they having the same symmetry, therefore they follow the Hund's rule. After singly occupying the orbital, they start pairing. Total 10 electron is present. We start filling the electron. We can calculate the bond order. 6 minus 4 divided by 2, we get 1. Here unpaired electron is present. The nature of magnetic property will be paramagnetic for boron molecule. Carbon molecule, its atomic number is 6, and in carbon molecule it contains 12 electrons. This is the diagram. While writing the electronic configuration, we can write like this. That means we can write the inner orbital as K shell, and also drawing the energy diagram, we can ignore this orbital. Directly we can draw the diagram from 2s 2p like this. Total 12 electron is present. In out of 12 electron, 4 electrons are present in K shells, and the remaining is 8 electron. The 8 electrons fill in 2s and 2p orbitals. 2, 4, 6 and 8. We can calculate the bond order for carbon molecule. 6 minus 2 divided by 2, we get 2. The bond order for carbon molecule is 2, and they are diamagnetic in nature. If you consider the complete electronic configuration, we can use bonding molecular orbitals 2, 4, 6 and 8. 8 minus 2 and 2. 4 divided by 2, we get 4 by 2, again we get 2. Nitrogen molecule, we know that electronic configuration or atomic number for the nitrogen is 7. In nitrogen molecule, the total electron become 14. We can write the electronic configuration like this. If you are neglecting the 1s inner orbital while drawing the diagram, you have to fill the total 10 electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 electrons we have to fill if you consider the diagram from 2s orbitals. The bond order will be 8 minus 2 divided by 2, that is equals to 3. And the magnetic nature, that is diamagnetic. Nitrogen molecule is diamagnetic in nature. Nitrogen ion N2 plus. Now out of 14 electron, we are removing the 1 electron, we get total 13 electron in N2 plus. Means in this diagram we just removing the 1 electron. If you remove the 1 electron from 2pz, you get the diagram like this, and the bond order will be 2.5. 7. 7 means 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7. And this is the anti-bonding molecular orbital. In anti-bonding molecular orbital, only 2 electrons is present. 7 minus 2 divided by 2, 5 by 2, we get 2.5. Because of unpaired electron, N2 plus is paramagnetic.